Hey guys, welcome to my first set on probability. These are aimed more at foundation, but of course everyone can try them. Let's go. Given first up, there are only blue, yellow, green and red counters in a bag. A counter is taken at random. The table shows the probability of getting blue, yellow or green, but they work out probability of getting red. Alright, so probability always adds together to 1. So if we add 0.2, 0.35 and 0.4, we get 0.95. So the probability of red is 1 minus that. So that's 0.05. Part B. What is the least number of counters in the bag? Alright, so for this, let's turn some of the probabilities into fractions. So, 0.2 is 2/10, or 1/5. So, for that to work, there would need to be 5 counters in the bag. If we look at 0.35, that's 35 over 100. Which simplifies to 7/20. So, for that to work, there would need to be at least 20 counters in the bag, which is the same as for 0.05. So, the answer is 20. And the reason being that's the smallest number that 0.35 and 0.05 work with. Number 2. An ordinary fair dice is rolled once. On the probability scale, mark with a cross the probability the dice will land on an odd number. Alright. So that's 3 out of 6, which is 1/2. Part B. Write down the probability the dice lands on a number greater than 4. So it can land on 5 or 6, so that's 2 out of 6. Which is 1/3. Next up, a number is picked from the first 4 prime numbers and a number is picked from the first 4 square numbers. The numbers are added to give a score. Part A, complete the table. Alright, so going across the top, our missing square is 4 times 4, which is 16. And going down the side, our missing prime is 5. Alright, so now we just add the number at the top to the number at the side. So, alright, there's our table. So then part B, what is the probability that the score is a prime number? Alright, so there are 16 possible outcomes. So it's going to be out of 16. Now let's count how many primes we have. So we got 1, 2, 3, 4, 5, 6. So it's 6 out of 16, which would be fine, or that's 3/8. Next up, in a game, 2 fair spinners are spun. If they land on different numbers, the score is the higher number. If they land on the same number, the score is 0. Part A wants us to complete this table. Alright, so 2-1 is 2. 2-2 is 0 because they are the same. 2-4 would be 4. 2-6 would be 6. 2-1 is 2. 2-2 again 0. 2-4, 4 and 2-6, 6. 3-1 is 3. 3-2 is 3. 3-4, 4. 3-6, 6. 5-1, 5. 5-2, 5. 5-4, 5. And 5-6, 6. Alright. Part B wants us to write down the probability that the score is an odd number. So again, it's out of 16. Now let's count how many odds we have. So we have so that's 5. So the answer is 5/16. Part C, the same game is then played with spinners C and D. We have the numbers on C, but not on D. So the table shows some possible scores, and our job is to fill in spinner D. Alright, so when there's a 1 on C and something on D, we get 4. So that means that there is a 4 there. Okay, next we get a 0 with a 4 on C. So that must mean there is a 4 again on D. Okay, then we get a 0 with a 7 on C, so there must be a 7 on D. And then we get an 8 when there's a 7 on C, so there must be an 8 on D. So anywhere on D we have 4, 4, 7, 8. Next up we have a probability scale with each event A, B, C and D. Part A, write the letter of the event that is certain. So if something is certain to happen, its probability is 1. So that's D. Then we want the letter of the event which is unlikely. So unlikely events are between 0 and 1/2, so that's B. Okay, then for part C, there are 12 counters in a bag. 3 are red, 1 is blue, 2 are yellow, and the rest are green. Okay, then takes a counter at random, show that the probability the counter is green or yellow is 2/3. Alright, so we need to work out how many green counters there are. So 3 add 1 add 2. Is 6. 12 take 6. It leaves us 6 green. So that means there are 6 green and 2 yellow. So 6 add 2 on a good day is 8. So the probability of green or yellow is 8 out of 12. Which is 2/3. Final question, so this time we have a spinner labelled 1, 2, 3 and 4. The table shows the probability it will land on 1 or 3 or 4. Part A wants us to work out the probability it will land on 2. So again, probability always adds up to 1. So we're going to do 0.2 add 0.4 add 0.1. And that gives us 0.7. So the probability of 2 is 1 minus 0.7, which is 0.3. Okay, part B. Which number is the spinner least likely to land on? So that's the number with the smallest probability. So that's 0.144. Given part C, Jake is going to spin the spinner 60 times. Work out an estimate for the number of times the spinner will land on 1. So the way we do that is multiply the number of spins by the probability of getting a 1. So we're doing 0.2 times 60. Now you can use your calculator, or that's the same as 1/5 of 60, so that's 12. That's the end of that one then, guys. Really hope it's helped. Hope to see you in the next video.